This is the video on optic tracts and visual changes. In this video, we will follow the pathways for visual input and explain what happens when something goes wrong with that part of the pathway. Starting at the eye, the first part of the path is the optic nerve. This nerve leaves the back of the eye and travels to the chiasm. If the nerve is cut or damaged, the person will be blind in that eye. At the chiasm, the axons from the medial retina cross to the other side. The axons from the lateral retina do not cross. The medial retina covers the lateral visual field. If the chiasm is cut or crushed on by a pituitary tumor growing in that area, the person will lose both lateral visual fields. This is like having blinders on. The person can only see in front of themselves and not to the side. Often, a pituitary tumor is diagnosed when a person hits a parked car because they simply could not see it. This is known as Bi-Temporal Hemianopia. Bi-temporal meaning both lateral fields, hemi meaning half, and anopia meaning blind or no sight. From the chiasm, the visual stimuli move to the thalamus through the optic tract. If the optic tract near the LGN is injured or part of a stroke, the person will lose vision in one visual field since the fibers have already crossed. So there is no vision in the left or the right visual field. This is known as Homonymous Hemianopia. Homonymous means the same side, so the same defect in both visual fields. From the LGN of the thalamus, the fibers can travel in a number of pathways. If there is a lesion in the loop of Meyer as it moves around the temporal lobe, the person will lose vision in the upper portion of one visual field. This is called congruous quadrantic homonymous hemianopia, or, more colloquially, pie-in-the-sky defect. Quadrantic means quarter of the visual field, so upper quadrant on the same side, blindness. If there is a lesion in the parietal radiations, you get the same type of defect as in the Meyer's loop, except that it is in the lower quadrant. This is inferior quadrantic homonymous hemianopia. If the lesion is present in the fibers that go straight back to the occipital lobe, you get a complete homonymous hemianopia, the same as you get from the thalamus itself. Remember, at the Calcarean fissure, the fovea area is the very tip of the occipital lobe, and it is supplied by a different artery than the occipital proper. If there is a stroke in the occipital lobe, you will get a homonymous hemianopia like in the LGN or main radiation area, except there will be a sparing of the fovea area. This is known as Macular Spuring homonymous hemianopia. If the very tip of the occipital lobe is injured, only the fovea area will be involved. This is called homonymous macular defect. Examining the visual changes after an injury or stroke can tell you a lot about where the stroke is located in the brain, even without an MRI. This ends the video on optic tracts and visual changes.